Okay, so here are two problems we talked about while the last video was uploading. If you notice, the last video doesn't have noise because I accidentally had my microphone turned off. My bad. You can pause and look these over if you want. We're going to go over 7 now. Okay. Oh, and we are on these problems here. So 7 is f of x is equal to 1 cosine squared e to the 2x. Okay, so you could, if you really wanted to, go through and start your quotient rule here. I don't recommend that. I really don't. This is one of our trig laws. Sine squared theta plus cosine squared theta is equal to 1. So if I have 1 minus a cosine squared, it's sine squared. So up here, we're going to replace this just to make our function easier to deal with. So we'll have a sine squared of an e to the 2x instead over a cosine e to the 2x. So once again, if we wanted, we could go into quotient rule here. But I'm going to make it so it's product rule just because I prefer product rule to quotient rule. If I have a sine over cosine, that becomes a tangent. But don't forget that this is being squared. So I'm going to have 2 sines on the top and 1 cosine on the bottom, so I'll have 1 tangent and 1 sine left over. So I'll have f of x equals a sine squared of e to the 2x times, not sine squared, shoot, sine of e to the 2x times a tangent of e to the 2x.
Why tangent?
Because sine over cosine equals tangent. Yeah. Just don't forget we can only do that if what they have on the inside is the same. Now we can go through and do our product rule. It's going to be combined with chain rule, so that's super fun. Let me double check that there's no other tricks I'm missing really quickly. Yeah. Okay, yeah, so we have to go from here. So I'm going to say that my u is equal to an e to the 2x. And then that means du is equal to a 2 times e to the 2x, because we do the derivative of our exponent times e to the same exponent, 2x. So I'm going to go and I'm going to replace that u. That means I have f of x equals a sine of u times a tangent of u.
What about the du?
So I haven't done a derivative yet.
Oh, okay.
Yeah, so now we're doing our derivative, f prime of x. So it's going to be my left function times the derivative of my right function. So my left function is sine of u times the derivative of the right, and the derivative of tangent is secant squared. So we have a secant squared of u. Now we add in that du. So you only add the du if you've taken a derivative. This is going to be plus, this was L dr, now we're going to do R dl. My rightward function is my tangent, so plus tan u times derivative of the left.
Cosine u.
Yep. Cosine u times du. Now, last thing, we're going to go through. I'm going to replace all of our u's and du's here. So f prime of x is going to be equal to the sine of an e to the 2x times a secant squared e to the 2x times 2e to the 2x. Then we'll have our addition sign in our next set. A tangent of e to the 2x times a cosine of e to the 2x times 2e to the 2x.
So ugly.
Yep. But for your response, you can leave it here. So, I mean, you could simplify a little bit because the secant squared, you could make that 1 over cosine squared, and you could make a tangent on that first one.
I'd rather make the
But-
teacher's job harder. Honestly.
Yeah. Well, it's likely that they would give you this on the, if they were giving you like the rubric, they would give you this, and then they'd be like, if they simplified, they should get to this.
Imagine people who have to do like all the answer keys for all the tests.
Super smart.
Where did the 10 come from? At the beginning?
This one?
No.
Oh, up here?
Yeah.
So that came from this, so I'm saying this is a sine of e to the 2x times a sine e to the 2x, because I had it squared over that cosine e to the 2x. And what I did was I took these two and I combined them into that tangent.
Oh, okay.
Yeah. Okay, so we're going to go over integrals now. We're going to do question 2, so take a second, copy that down, pause the video. Okay. So for 2, we have trig, and we have fractions, so we're going to have to use u sub. So, yep.
X dx.
Yep. Okay. So once we're here, first thing is we can actually replace tan squared x plus 1 with something. This is another one of our trig laws. So tan squared x plus 1 is actually equal to a secant squared of x. So before was our sine and cosine law. This is our tangent law. It's all the same equation technically though, because what we're doing is we're taking it and dividing it by a cosine squared. So if I had my sine, I don't know why I wrote a z, sine squared x plus cosine squared x equals 1. Well, if I divide this by the cosine squared of x, cosine squared of x, here we have to distribute that. So sine over cosine is a tangent. We have that twice though because of the square. So that gets us our tangent square x. Plus, well, these cancel because they're the same. So plus 1 is equal to, well, I can rewrite a 1 over cosine as a secant, but it's squared so we have 2 of them. So secant squared of x. So you can also do this with sine squared. You could divide both sides by sine squared. Instead of a secant, you would have a cosecant over here. Your 1 would be on the left. But you would have a plus cotangent squared. Okay. Do we feel good with that trig law?
Mm-hmm.
Okay. Maybe not remember right away, but
Understood.
it makes sense. Okay, so what we're doing is I'm going to take that top, replace it with secant squared, integral secant squared of x over tan x dx. So we always want to look for things and their derivatives if we're trying to find our u. It's also, we're looking for something that is the most inside of our equation.
Yeah.
So denominator.
Denominator. So one of the places we look is our denominator. In my denominator, I have a tan x. And can I see its derivative?
Yeah.
Yeah. So that means we're going to make our u equal to tan x. Meaning my du is equal to a secant squared x dx.
Bye.
Huh?
I got your bill.
Yeah.
You should have said hi for me.
How come? You can say hi to him in person.
Okay.
I swear he's such a weirdo.
Okay.
He's just like, it's the thing he does.
He's so different from you. Like, okay, so now plug our u in. We have our integral of a 1 over u times du. So this whole part that I'm circling in blue, that became du. And then our tan x was our u. Now, are we going to use power rule?
No.
No. Because I could rewrite this as the integral of u to the negative 1 du. You would think power rule, right?
Mm-hmm.
But what's negative 1 plus 1?
0.
0. Do I want a 0 in my power?
No.
Nah. Don't do this. What do we do instead?
LN.
Ah. That's not what I'm trying to write. Natural log of u. Plus?
Oh.
Oh. I was like too busy writing to.
It was like,
I know, you all just like froze. Okay, natural log of u plus c. Now we go back and we plug our u back in. So this is going to be equal to the natural log of the absolute value of a tan x plus c. Okay. Oh, I was looking at the wrong question. I was like, how did they get that? Never mind. I was looking at question 1 on the answer sheet and I was so confused momentarily. Okay. Cool. Oh, it wasn't recording.
8 seems easy.
Here is the document if you need it. It's also on the website for you to download.